Question 9. The population of a town increases by 3% every year. In the year 2000, the population was 3,000. Find the population in the year 2003. Merely looking at this question, you should know that this question is a compound interest question. There's a short method, a shortcut to doing this. There's a constant increase by 3%. Then you can apply compound interest formula. A equals P into bracket 1 plus R close bracket to the power of T. In this case, our A is the population of the year in 2003. That's 3 years after that. So you have the year 2000, and the next year is 2001, 2002, and 2003. So you have 2001, 2002, and 2003. These are 3 years. So our T is 3. Then our R, which is the rate, is 3%. Our principal, or this time our initial population, or our first population, is 3,000. So with this, we can find the population in the year 2003. As you can say, population in the year 2003, or A equals our initial population is 3,000 into open bracket 1 plus our rate is 3, so you make it 3 over 100. You have to make it 3 over 100. Close bracket. Our time, which is up here, is 3. On the next line, you have A equals 3,000 into open bracket 1 plus, you divide 3 by 100 will give you 0.03 to the power of 3. Our A equals 3,000 into open bracket 1 plus 0.03 will be 1.03 to the power of 3. Our A equals 3,000 into open bracket 1.03 to the power of 3 using our calculator will give you 1.093. On the next line, we have 3,000 times 1.093. A equals 3,278.181. A is approximately 3,278 to the nearest whole number. The answer is B. There's also a method you can use. You can choose to increase it by 3% every year. You find 3% of 3,000, then the result you add it to 3,000. Then you go for the next year. The answer you get, you find 3% of it, then you add it to the new population, then same happens to the third year. That since you're increasing it by 3%, you can just find 103% of 3,000 for the first year. You don't need to add this time. Then for the next year, 103% of the new population, then same happens to the third year. As noted in our conversation, since it's increased at 3% every year, let's start from the initial year was year 2000, which was 3,000. The population was 3,000. In the year 2001, the population increased by 3%. First, you might have to, like said earlier, you might have to find 3% of 3,000. Then you add the result to the 3,000. But in some cases, you don't need to do that. Since you know it's increasing by 3, or it increases by 3%, you add 100 to the 3% increase. That will give you 103. Then you do 103% of 3,000. 103% of 3,000 is 103 over 100 times 3,000. 0 cancels 0, 0 cancels 0. So you have 103 times 30, which will give us, for the first year, that's 2001, you get 3,090. The next year is 2002, which is, you still find 3% of this and add it to this value, the new population in the year 2001. For this, you can just, rather than find 3% of this amount, then you now have to add results to this. You can just simply, like done before, this is like 100%, the value is 100%. Since it's a 3% increase, if it were a 3% decrease, you subtract 3 from 100, that will be 97. Then you do 97% of 3,090. Since it's a 3% increase, so you have it as 103 over 100 times 3,090. 0 cancels 0. Then you have 103 times 309 divided by 10, which gives us 3,182.7. For the last year, which is 2003, you still have 103 over 100 times 3,182.7. So our calculator will multiply 103 times 3,182.7, then divide our answer by 100. Our result is 3,278.181. Now, like the first answer, it's approximately 3,278, because when you approximate this one, since it's not up to 5, it doesn't add anything to these digits. Either of the methods can solve this question. You can either choose to use the formula method, or you can find 3% of the amount per time or per year, then add the result to that number that you found 3% of.